Hello and welcome to our demo webinar session today, how to transfer or create parameter sets with Flow Developer. My name is Mike Rogerson and I'll be your host today. Joining me will be Anna Montez and Gene Miller, and we will meet them later. Before we get into the demo, let's establish a little bit of context on why Velo3D wanted to offer a product like this. So if you look at this chart and you see on the left-hand side, this is the traditional AM market where it's been used for small production runs, project work, prototyping, potentially some maintenance, flex production, high mix, low volume work. What happens in many cases, though, is as you ramp the volume up, as you increase the volume required, it gets replaced and we transition from AM to something like casting or maybe CNC. So this has been the traditional market of AM. What we're seeing with AM today, the new market with space and hypersonics potentially coming down the line, is we have designs that are only enabled by AM. These are designs that are unlocked with the design freedom that you find in AM. And so while these are powerful and bring a lot of opportunities, they also bring a lot of challenges. So if you kind of look through the process of moving from R&D into production, what a number of engineers have tried to do after investing years and years of effort and millions of dollars is they try to just replicate on the same platform with the same model number. They get another of that exact same system, and they try to move the process from system A to system B. But what they find is that it's not that simple in additive manufacturing, and that it takes additional non-recurring expenses or NRE. It takes additional investment and calibration, maybe even some parameter tuning. So it's not reproducible in that sense. So they go to plan B and they try to transfer from their R&D platform into something that might offer a benefit in terms of reproducibility in production. And until recently, this has also been challenging. So if you kind of look at that first slide again, and really break it down, you look at the right-hand side again, you actually have two segments. You have designs that are enabled by AM, but then you have the same transfer into the need for scalability, and there's a gap there. And that gap is mainly why we've developed Flow Developer. And if you have designs that are created on Velo3D, or if you have designs that are not created on 3D, we wanted to have a streamlined conduit into scalable production for additive manufacturing. And that's what we're going to talk about in some detail today. Let me introduce our speakers. So here joining us today, Gene Miller. He has held various positions in process engineering and foundry metallurgy before joining Velo3D in 2016, where he played a role in developing the unique processes used on Velo3D Sapphire technology. Gene currently serves as Applications Training Manager and holds a BS from Colorado State University. Also joining us is Anna Montez. She joined in the same year in 2016. She has held various roles in process engineering, focusing on developing, characterizing, and optimizing novel laser powder bed processes for a variety of materials. In her current role as Principal Technologist, Anna is driving process and material qualification efforts while also collaborating in the development of Velo3D's new process parameter editor, Flow Developer. Anna has a PhD in mechanical engineering from Northwestern University with a focus on material science. And with that, Gene, I'll turn it over to you.
Thanks, Mike. So from a high level, looking at all the products that Velo offers, we try to be a one-stop shop and giving the users one solution for each step of the way under one envelope. And we're going to talk about Developer, which is a new piece of the puzzle found in our print preparation software called Flow. Flow is responsible for developing the print file, which is then used on the Sapphire family of metal printers to print the part. And in those two processes, a lot of data is generated, and that's where Assure comes in to gather all those data and present it in a digestible form to the user. On a little bit deeper level, Flow is capable of retaining native CAD fidelity. This helps in print preparation as well as fidelity in the printing process. And Flow is also equipped with an inspector tool. We use this to verify and validate that all the laser commands and laser processes are behaving as expected and as intended by the user. And we'll get into that a little bit later. But main and primarily, we're going to be talking about Developer today. This is our new a capability built into the Flow software for users to develop and optimize their own parameters using Velo Sapphire technology. Also incorporated this year is a new product called Pan Optimization. This is a new simulation tool where prints can be thermally simulated before the printing process actually occurs. The Sapphire family consists of many different configurations of the Sapphire printer, but the largest capable is a 600 millimeter by 1 meter tall high print volume. Each machine will come factory or come standard with factory and on-site calibration. So we're really pushing for machine matching across the fleet, and each is equipped with 1 kilowatt variable spot size lasers. So a nice wide process window, or a nice wide capability to accept many different processes. And these machines are equipped with built-in multi-laser alignment, optimized for gas flow, as well as a non-contact recoder to help expand and enlarge that process window that users so seek. The printing process, there's nearly 1,000 sensors gathering data throughout that time. And like I said, that's where Assure really comes in, gathers all these data from preprint and the printing process, and coordinates them in a digestible form for the user to generate an on-demand build report. This is a great way to ensure quality in each part, and if there are any anomalies or build stoppages, they are immediately highlighted and brought to the user's attention. We've also integrated Grafana so that the user can see in-depth readings on these sensors if you really want to get into the raw data side of things. So from a real high level, what are we really trying to enable here? Process development is based on finding a process window and parking your process in an optimal space. And we're trying to enable users and developers to have a tool that does that a little bit better. Traditional laser powder bed fusion printers with a traditional recoder are plagued by protrusions, and that threshold is encountered much quicker than on a Sapphire technology machine that's utilizing a non-contact recoder. And on two ends of the spectrum here, you typically have too little energy, where you run into problems of lack of fusion porosity. And then in the exact other end of the spectrum, where you put too much energy down, you might start overheating your substrate, leading to keyhole porosity. So having the ability to park your process somewhere in between the two is the goal of our technology for our users. So one of the first use cases we want to talk about and why we really did this was to embrace our customers' prior knowledge of processes. Until now, customers that did prior process development on other machines could not use those processes on a Sapphire. Well, we're opening that up. That changes now. Customers like Ursa Major that we've worked with have had a seamless integration of their prior processes developed on other machines, using them on a Sapphire machine. We not only want this to be something that is done once, but also repeatable. So the next step of why developer is going to be so powerful is enabling our users to optimize their objectives or guide their objectives towards a goal, whether it be from surface roughness or overall throughput. Users are empowered to change layer thickness, laser speed, spot size, power, hatch spacing, etc., to really push the envelope to increase throughput on the machine if that's what they're after. Mentioned this a little bit earlier, the process transparency, everything that you develop in Developer you are able to see and inspect in the inspector tool in Flow. You'll be able to see everything from spot sizes to all the laser paths to the hatch spacings, powers, focus. Everything is there so that you can validate that the processes are being applied as intended and is actually what's happening in the printing process. So this is another thing I'm really excited that we are enabling until now. The only way that a customer could get a new material is if the Velo 3D process engineering team did material development on it. Well, another thing that stops now, we're opening up the door so that customers can do their own material development. They can seek out new materials that might be a better business case. They can even find new and more beneficial powder suppliers with better commercial terms, maybe shorter lead times or better quality, and do their own development. And they don't have to wait for Velo to do it for them. So scaling is the most important part when it comes to what our objectives are. Printing a part once is great, but printing it 100 times with the same result is the ultimate goal. To make additive manufacturing an actual scalable, realistic manufacturing option. And we do this through establishing a factory and on-site fingerprint or a stringent calibration of each machine. And then over the lifetime of the machine, we have built-in health checks that are run at about a weekly cadence to ensure that each machine is maintaining that high level of calibration, such that when we put that same print file on multiple different machines, we can expect the same result. And also getting back to the wide opportunity for embracing many different processes. Having a high power laser with variable spot sizes can accommodate many of these different processes that customers want to explore or have developed on other machines. And then finally, the non-contact recoder, enabling a wider process window for our customers to really push the envelope of what's capable with laser powder bed fusion. And with that, I will let Anna take it over and give the demonstration of the Flow Developer tool.
Thank you, Gene. So Developer was designed as a toolkit for process engineers to bring their existing knowledge and expertise into the Velo3D platform. So today we'll be doing a demonstration and we'll be seeing which parameters are editable, how to edit those parameters to create your own parameter sets, saving and sharing parameter sets, and then working with external sources for design of experiments. And finally, how to prepare a file for printing and inspect it. So with that, let's get started. And what I have here is our Flow print preparation software. I have already selected the printer that I want to use, Sapphire in this case. And I have already selected as well my material, Inconel 718. Usually when you're preparing a build file, you import your CAD, which I've done already. I have here 3 geometries of interest. And you locate your parts where you want, orient them however you want. And if you want to use a process parameter different from the default for Inconel 718, then you can go into Group, Process Set, and we have a list of process parameters available for that material. You can see here the options for Inconel 718. They're separated based on core power, layer thickness, so on and so forth. With the release of Developer, we are establishing a new class of process recipes that are customer editable. Those recipes can be used in conjunction with the normal offerings that we have for a given material. And they can be found up here in the list of process sets. You see that we have 2 different options available for customer editable recipes. The first one is basic recipes. And basic recipes are traditional laser powder bed fusion recipes that are meant to be used for parts designed following standard additive manufacturing guidelines. Our process engineers have spent some time developing and characterizing these recipes to understand their capabilities and limitations. As any traditional LPBF process parameter, the basic recipes, when you're using them, you need to support low angle overhangs. We currently have basic recipes available for Inconel 718, Inconel 625, and GRCOP 42. Now, the second option that you have available is templates. And templates are available for all our material offerings. And they are almost a blank starting point for you to do process development and to build your recipe however you want. Now, when you want to use developer, you want to select one of these two options. In this case, let me go with basic. And you can access the editor here through the developer menu. You go into developer, edit parameter sets, and that brings this window over here. You can see that we have in this first column a list of all the process parameters that you'll be able to modify. And we have a column for each of the parts that you have in your build layout so that you can change the settings for each. We have some general settings like layer thickness, for instance, that apply to your entire part. But then we also have some feature-specific settings, like settings for supports, for core, for skins, so on and so forth. We have collapsible menus that allow you to access parameters within each of these groups. So starting with core, core is basically the inside of your part. And what we have here in core for parameters that you'll be able to change, we have an area fill. In area fill, you're able to establish how you want exactly your laser to fill the core area. So in that sense, we have settings, for instance, to determine what kind of hatch pattern you want to use, for you to define what hatch spacing you would like. We have settings, for instance, if you want any particular hatch angles, you can define them under prescribed angles. And we have settings for extending the length of your hatches at the start or at the end, if that's something that you'd like to do, and many more, as you can see here. That really gives you the flexibility to define your core process however you want. Now, of course, we have laser parameters for core, where you'll be able to define the core laser speed, laser power, and laser spot size. Now, moving on to skins. Skins are the regions near the surface of a part. And we handle 3 different types of skins. So let me bring this diagram to explain what they are. I have here an arch structure where you see that in colors, I have marked the skin areas. And you see that bottom skins are downward facing surfaces in the angle range 0 degrees to a user-defined angle theta. We have top skins that are upward facing surfaces in the angle range alpha to 180 degrees. And then we have intermediate skins to cover the range in between bottom and top skins. Going back to flow, here in the parameter editor, you can see that we have groups for each of these skins where you'll be able to modify the settings for each.
So Anna, I see there's a lot of numbers with brackets around them. What does that signify?
Yes, that's a good question. So in developer, some parameters are array type, meaning that you can define multiple array items of the same kind. Such is the case for intermediate skins here, where you see the number 3 in square brackets. If you open that, you see that I have defined 3 different intermediate skins for different angle ranges. Now, one distinction that should be made is that not all skins are treated equally. Bottom skins and top skins have area fills, very similar to core, where you define how exactly you want your laser to fill that skin area. Intermediate skins, on the other hand, they invoke contours to follow the edges of the part. The contour settings themselves are not defined here in intermediate skins, but we have a group for that down here under contours, where you specify however many contours you want, you give them a name, and you define the characteristics of each contour. So things like laser parameters, whether you want the contour to have a given offset from the edge, so on and so forth. But then what you do is from intermediate skins, you reference the contours that you want to use for that particular angle range. The benefit of this is that you only have to define your contour settings once, but then you can reuse them in multiple intermediate skins if that's something you want to do. Now, we also have here settings for supports, for lattices, and for thin walls. And as you see, those are also array type parameters, meaning that you can define settings as a function of radii in the case of supports and lattices. And in the case of thin walls, you can define settings as a function of wall thickness. Now, we have great documentation available from the developer menu on all of the parameters available, what they do and how to use them. But if you ever want a quick explanation on what a given parameter does, you can hover over it and you get a short description of that parameter. Now, that covers at a glance the parameters that we have available for editing. Now let's move into how do you actually edit this. So let's say that I want to modify core laser power. So I'm going to be modifying that for my first part called block. I just click on that cell, input a new value, and hit enter. You see that when I did that change, my cell was colored green, meaning that I made a valid change. Also, you see that the parent cells are colored green as well, so that if my menus are collapsed, I can easily recognize where changes have been made. Now, if for some reason you input a value that is not valid, the cell will be colored red. Whenever you have errors like this, you see that the OK button down here to accept changes is grayed out, meaning that you won't be able to proceed to your build layout before fixing your errors. Now, if you hover over that cell, you also get a useful message on what the error is. In this case, it's telling me that I input a value that's above the maximum allowed power of 1,000. So I need to correct that in order to be able to move on. Now, in order to transfer information from one cell to another, we have the typical control copy, control paste operations that you can use. We also have control C to undo. But then we also have right-click menus available that give you a few more options. Over here, you see that we have copy paste. You can reset a value to the original one. You can propagate your value to the columns to the right, for instance. And then if you want, you can do control copy and paste a value across so that you transfer that value to the entire row. Now, for array type parameters, a right click also gives you options to add array items or remove array items. Now, let's say that you've worked on the first part and you've changed a few things in regards to how exactly you want your core process to be. Let me change here a few things. And you want to transfer those changes to a different part over here. If you do a right click in the name of the process recipe, you get, again, copy paste operations that will allow you to transfer all the changes to a different part. You also have the option to reset all the values. Now, let's say that you've worked on your recipe and you've built it up, and that potentially you want to reuse it later on in a different build or want to share it with your team. How do you go about doing that? So for that, you have two options. Both of them are available here by doing a right click in the name of your part. And I'm going to be talking first about patches. So patches are a list of all the changes that you've made on top of your initially selected recipe. You can use copy patch, paste patch to transfer information here within your current developer session. Or you can save patch as, which will save a JSON file, again, with the list of all changes that you've made. Later on, in a different flow session for a different part, you can use the option patch current values from, and you select that JSON file to bring the changes to that part. Now, since Patches are a list of changes that were done on top of an initial recipe. We do recommend that for effective use of patches, the recipe that you selected initially for generating that patch matches the recipe where you are applying that patch. Patches are very useful when you're doing experimentation and when you, for instance, have found a condition that you like, that you want to continue using in other experiments to fine-tune it. But we have an option here that I would say is more suited for when you've already built a process recipe that you're very happy with, that you're very comfortable with. Perhaps you've qualified it and you want to continue using it in many other parts and builds. So for that, we have this option to export parameter set. And with that option, you can save a file with the VELOParam extension, as you see here. Later on, in a different flow session, you can import that parameter by going here into Developer, Add Parameter Set, and selecting it. The advantage here is that the VELOParam file will contain not just the list of changes, but it will contain all the information for that process parameter set. Let's go ahead and select that. And now, if I want to assign that process set to my parts, I have my custom process available there in the list for me to select.
And this is all really cool. What other process advanced features are available in the developer?
Yes, I would say that there are two nice features that are available in developer. Oftentimes when you're doing experimentation, you can have a lot of parts in your build layout, maybe tens or even hundreds. And you want to check the settings for one of them, for instance. So one nice thing that we have is you can select a part and go into developer, and it will show you that part that you have selected. So that really simplifies your workflow there. Now, the second feature that allows you to work more effectively with developer is the use of filters. You see that we have here a very long list of everything that you can change. And sometimes you just want to focus on some specific parameters, not all of them. For instance, let's say that you're developing the core recipe. You just want to optimize laser parameters and patch spacing to get good density. So what you can do is you can select those parameters of interest, do a right click, add selection to filter, and you see that it highlighted those settings in a different color. Let me do that as well for hatch spacing, add selection to filter. And then I can right click anywhere here in this column and enable my filters. So that brings a simplified view of the parameter editor, which is really useful, again, when you're focusing only on a few of these settings. You can always go back to the normal view by using a right click and disabling your filters. And you have options to remove a given parameter from your filter selection, or even to clear all your filters. Okay. So now let's talk about design of experiments. When you're designing an experiment, oftentimes you have selected a list of variables that you want to experiment with, and you have certain levels for those variables that you want to test. It's very common that you may use a statistical program to design your experiment, where you're doing certain combination of your different levels of variables. And you may have that design, again, in a different program or even in a spreadsheet, where you're having the list of samples that you want to test with all the conditions. So I have an example here. Let's say that you're doing an experiment on core laser parameters. And you have 9 samples that you want to test out with this combination of settings. How do you go about transferring that information into Flow? So let's go ahead and try that. What I'm going to be doing is I'm going to leave just this part. Let's say this is my test structure of interest. And I'm going to be duplicating it so I get the number of parts that I need for my experiment. Okay, when I did that duplication operation, you see that all my parts are still contained in a single group. So that means that if I open developer at this point, I'm going to get a single column for this group of parts. What I need to do is break this group up so I can select all my parts. And do instance, create new groups. And you see that that broke my group up. Now, if I open developer, I'll see one column for each of my parts here in the build layout. And transferring information from an external source is very simple. I just need to do a control copy. I go to my first part, I do a right click and paste row, and that brings all the information. You see that it automatically did the transpose from column to row, which is really nice. Let's do the same for power, paste row, and so on and so forth. You can do this for as many parameters as you want. When you're happy with your experiment here, you can click OK. And you can finalize details on your build layout and how you want your parts to be. Now, sometimes it happens that you're working with developer, you have already put there all the settings that you want, and then you realize that actually you wanted a slightly different geometry here. I really don't want to delete all my parts and start over again. So we have a nice feature that allows you to change the cat file. Oh, sorry. We're going to go here into edit group for the first part. And we're going to be updating that cat to a different one. Okay. Now what I can do is I can select all of my parts and go into group and propagate that change. So you see that all the geometries have now been updated without me having to, again, input the settings in developer, and I should be good to go. Now, when you're happy with your build layout and your conditions, you should be ready to save your file. So we go into File, Save, and then prepare your file by going into Prepare and Prepare for Printing over there. Now, I have already prepared my print file to save us some time, and I have it open here in Inspector. So Inspector allows us to visualize all the different laser paths, every layer. So what you see here are my parts, and we can inspect all of the different layers. This is a progress bar where you're able to see, as a function of height or layer, what your laser commands are doing. Now, you see here that I have the option to color my laser paths, and I have selected to color as a function of what laser I'm using. In this case, it's showing me that these parts are being processed with my laser too. I also have the option to color by different settings. So for instance, I can select power, And you see here the color scale where it shows me how or what power is being used for each of the laser tracks here. We can do the same for speed, spot size, so on and so forth. Even we can color by name and be able to visualize where specifically, my core is, which contour is being applied where, and be able to check that everything is as you expect it to be. Once you're happy with your file and you have verified that it's doing what you want, you should be ready to use this print file to generate your parts in the Velo printer. So that's the demo.
So just to wrap up what we talked about here today, the new Flow developer is something that enables our customers to do something that they've requested for a long time. As far as I can remember, our customers have always wanted to do their own development, to really dig into the process, and now we're allowing that. So with Flow 7 available next month will come Flow Developer, this new feature to enhance a new level of freedom for our engineers. And personally, I'm really excited to see what our customers can develop with this new capability. We'll open up the floor for any questions.
Thanks, Gene. So we did have a couple questions, and one of them mentions, are patches forward compatible in the Flow software versions?
Yes, in general terms, they should be.
Okay. And I guess in this context, could you talk a little bit about the Flow versions where this software or where Flow Developer is available, in case people look at their current version and don't see the menu items you just showed?
Yeah, Developer will be available in Flow 7.0, being released next month.
There's a question from David. He asks, can you export as a CSV file?
Not at the moment, no.
Or, sorry, export the parameter set as CSV. Okay. I think it's not at the moment.
No, you will save as a VELOParam file so that you can later bring it into Flow.
Okay. There was another question. Can you print a single part with more than one layer thickness?
No, so layer thickness is assigned per part, right? So you assign a given value and that will apply to your entire part. But what you can do is, if you need for a given geometry to use different layer thickness for different sections, you can accomplish that through the use of assemblies. So basically you're partitioning your geometry, and in that way you can apply to one section one parameter with 50 micron, for instance, and to another section another setting that's 100 micron.
Okay, so you could kind of just merge the two. I guess when it comes out of the
Correct.
printer, it's basically one part, but software-wise, it's
correct. Yes.
David also asked, does Velo 3D use a 3MF based file type?
So we allow 3MF import to use as geometry, and we can export a 3MF mesh of the Velo build file. The meshing that actually goes into the printer itself is one of our own design, but you can import and export 3MFs from Flow.
Perfect. And Carl asks, is there a low angle limit to the customization parameters? How low can you go?
Not really. You can, so we have it open for you to customize everything, right? From bottom skins all the way to top skins. You're allowed to change the settings as you want.
And is there a limit on how many, like you showed intermediate skins and you said you could add different options. Is there a limit to how many of those you can make?
No, you can make as many as you want. We do recommend that, I mean, you don't want to go crazy as well, because every time that you have different skins with different contours, you may enter into problems where you have a transition line, for instance, in the printed part, if you haven't really optimized the offset for those contours, and so on and so forth. So sometimes it's better to keep it simple and not go extra crazy with the number of array items that you define.
No, that's good advice. And you showed a number of different variables there. Some of them I remember like power, speed, spot size. What are the ranges that you're able to do? You showed that one of the power ratings turned the cell red. Are there limits to all of those?
Yes, we do have them, and they will show in developer. When you hover over a parameter, you see also the constraints there. So for power, our maximum power is 1,000 watts. For spot size, you can go to 500 microns in terms of spot size in the higher side, and in the lower side, you can go to 75 microns. And then in terms of speed, I think the maximum is 4,000 millimeters per second.
Excellent. Well, that's all the questions I'm seeing. So I think everybody got their questions asked. If somebody comes up with a question later, what's the best way to get in touch with us to find out more about Flow Developer?
I would go to velo3d.com and ask to speak to an applications engineer or an engineer, and that's the best way to get in touch with us.
Perfect. And I understand we're also developing more content over the next couple of months that they could potentially reference as well.
Yeah, so there's some new learning training session and modules that are going to be coming out in the next months to really walk our users through Flow, through the printing process, to gather a deeper understanding of what's going on with the metal. And that's all going to be made available to our customers free of charge.
Perfect. And I'll add on to that. We are recording this session. I did get that question. I always get that question. We do record these sessions, these webinar sessions. They will be made available on YouTube. Give us about 48 hours or so to process the recording, and you'll be able to find it and reference it anytime you like. And as Anna mentioned, there are already documentation or documents on that detail how to use Flow Developer that do a very good job of that. I've got a chance to read through one of those already. She does a great job on putting those together. So lots of resources out there for anybody who wants to learn more about it. I'd like to say thank you to our audience today for joining us. Great session, great questions. And Anna and Jean, thank you for your presentations. Very informative as always, and looking forward to more things coming in the future.
Thank you, Mike.
Yeah, thank you very much.